Hello, welcome back to the VDC space. Today we're going to be doing a concrete girder bridge. Before I get started with the project, can you please, guys, subscribe to the channel if you're new to the channel, and if you're already subscribed, thank you. And hit the notification button because I upload Revit and BIM modeling tutorials 3 times every week. I cover different topics. As you can see on my playlist, you'll see that I cover different civil engineering and architectural and construction topics. So yeah, let's start with our concrete girder bridge. Let's scope it, define our BIM goal, level of detail, and the elements we are going to include for our 3D model. So for our scope, it's going to be a 3D modeling of a concrete girder bridge. Our BIM goal is going to be 3D visualization and quantity takeoff. So we're going to produce a schedule after we produce our 3D model. And level of detail, we're going to keep it from 300 to 400. And then the inclusions, the elements or components we are going to include in our 3D model is going to be the piles, the blinding layer, the bases, pier shafts, pier head, abutments, elastomeric bearings, Astro Type V girder, concrete deck, asphalt, parapets, barriers, approach slab, cobble, and deviator. So those are the elements you are going to include. So the first thing you're going to do is we're going to open up a new project using the construction template, and then we're just gonna uncheck these, and then we're just gonna extend these views and elevations because it's gonna be a large bridge. So we're gonna extend it by 50,000 from all the sides. And then we're going to extend it also this side. And then we're going to extend it also this side. Actually, we can extend it further from this side by further 50,000, and also this side by further 50,000. Perfect. So we're going to increase the scale to 1:200. So yeah, this is what we have. And now we're gonna set up our grids. So we are in level 0, so we're gonna set up our grids. So we're gonna place your vertical grids first, and then you're gonna name it. Actually, before we naming it, we just gonna set up our offset. So you go to pick lines and then set it to 30,000 millimeters offset. So we're gonna place 7 of them. So it's 2, 3, 4, 5, 6, and 7. Perfect. So now I'm just gonna center them just to see them clearly, and then I'm gonna place a grid that's running across and horizontal grids. Before doing that, I'm just gonna rename this grid. So I'm gonna name this one AB1 for abutment 1 and press enter. And then this one I'm gonna name it pier-1, enter. And then I'm gonna do the same thing for the others. So it's gonna be pier-2, enter. Then pier-3, enter. Pier-4, enter. Pier-5, enter. And then this one we're gonna name it AB-2 for abutment 2. And now we're gonna place our grid that are running across. So I'm gonna first place this one, and then I'm gonna rename this one to CL for center line, and then I'm gonna press enter, and then I'm gonna offset 3 of them from each side, and then offset them by 2,000 millimeters. So I'm gonna go with grid again, and then pick lines, and then select my offset, set my offset to 2,000. So I'm gonna offset it 3 times this side. So it's going to be 1, 2, 3, and this side also 1, 2, 3. Perfect. And now I'm gonna reduce my scale and set it back to 1 is to 100, just so I can see everything more clearly. And then I'm gonna rename this grid to G1 for Girder 1, and then this one G-2, enter for Girder 2, and then this one G-3 for Girder 3, and then we're gonna skip the center line, and then this one G-4 for Girder 4, and then this one G-5 for Girder 5, and then this one G-6 for Girder 6. And now I want us to distinguish the center line grid, so I'm gonna press it and say I'm gonna unlock it so that I can move it alone instead of moving them all together. So I'm gonna extend it from both sides. As you can see, when it's locked, it moves all the grids. So I'm just gonna unlock it also this side so I can move uh, it so that it can move by itself alone. So yeah, in order for me to distinguish the center line, I just wanted to extend it beyond these ones. So yeah, we set up our grids. So the next thing is, obviously, we're gonna set up our levels. So you're gonna go to the south elevation, and then you're gonna just extend your grids. And then as you can see, we cannot see our grids. I'm gonna go back to level 0 and then select my views, and then I'm going to extend the extent of my views beyond these grids so that I can see them on our elevations. So I'm going to set it like this, and then do the same thing on when it comes to other elevations. So I'm just going to select it like this, and then extend the view extend of my elevations. Perfect. Now when I go back to the south elevation, I can see my levels. Now instead of me dragging my levels beyond my grids, I'm just going to select one and then right click and say maximize 3D extend, so it automatically extends. So I'm going to do the same thing for the other one, and then I'm going to add more levels and then rename them. So I'm going to choose my level and then randomly place them. So I'm gonna have 5 levels. So I'm gonna place the fourth one and then the fifth one also. And now starting with the level 0, I'm gonna rename it to 00 dash, and then I'm gonna name it piles, and then enter. And then level 1, I'm gonna name it 01 dash bases, enter. And then I'm gonna set the height to 2000 millimeters, enter. And then level 2, I'm gonna change it to 02 dash, and then I'm gonna name it PS, enter. And then I'm gonna set the offset to 14,800 millimeters. And then level 3, I'm gonna select it and then rename it to 03 and then dash. And then I'm gonna name it girders, enter. And then I'm gonna set the offset to 15,422 millimeters. So I'm just gonna check this just to see them more clearly. And then the last one, I'm gonna name it 04, and then I'm gonna say dash and say deck, and then enter, and then set it the offset to 17,022 millimeters. Perfect. Now we are done with our levels. So the next thing is I want to work with the structural plans. So there are some levels missing on our structural plans. So I'm going to go to view, and then under create, I'm going to go to plan views and then drop down and say structural plan, and then select these two, and then make sure this box is checked. Do not duplicate existing views and say okay. And now everything is there. So I'm just gonna close every floor level down, and then the next thing is I'm gonna go to my basis structural floor plan. Before I place my piles, I like to place my bases first, so it's easier for me to use them as reference when it comes to the placement of my piles and the offset of my piles. So yeah, that's how I tackle things. So I'm gonna start with the basis of my piers first instead of my abutments first. So I'm gonna go to insert, load family, and then I'm gonna go to metric library, UK contents, and say structural foundations. And then I'm gonna go with footing rectangular and say open. And now I'm gonna go to structure under foundation. I'm gonna go to isolated. And now I'm gonna place my footing. So I'm gonna place it right on. Okay, let's start from left to right. So we're gonna start where pier number one and the center line are intersecting. So I'm gonna place my foundation there. And now I'm gonna select my foundation and change its parameters. I'm gonna go to edit tab and say duplicate. And then I'm gonna change this to 12,000 by 3,500 by 2,000 millimeters and say okay. So I'm gonna change the length to 12,000, the width to 3,500, and then the thickness to 2,000 millimeters. Apply and then okay. So this is what we have. And then obviously I'm gonna copy it to the other grids. So this is what we have. So we are excluding the basis for the pulse because they're gonna differ in parameters. So now we're gonna place our piles for our bases. So in order for us to do that, we're gonna go to insert and say load family, and then still under metric library, under UK contents, under structural foundations, we're gonna go with piles. And as you can see, Autodesk somehow has only steel piles instead of concrete, which is very much annoying, especially when you want to separate the elements. If you go with the bases that go along with the piles, it is concrete. That's the good side. But the downside is when you try to create a construction model whereby you want to separate elements as much as you can, you only have the steel pipe. But that's not a problem. We can still solve it. So you're gonna say open, select your steel pile, go to structure, under foundation. You're gonna go to isolated, and then change this to 600, the largest one, and then place it right in the middle, and then select it, and then go to edit family. So we're gonna make it our own family. And now we're gonna say under structural material for model behavior, we're gonna change it from steel to concrete. And then under properties, you're gonna go to family types and then change the structural material and type in concrete, and then you're gonna drop down and then set it to, you can set it to concrete precast and say apply, okay, apply, and then okay. So when you extend this and say material for model behavior, you can set it to precast concrete. And now you can save this as your own family. You're gonna say save, and then I'm just gonna save this under documents. I'm just gonna create a new folder and name it Girder Bridge model. And then I'm gonna save this as concrete pile and say save. And then I'm gonna load into project and close. And then I'm gonna go back to my basis floor plan, select my pile, and then drop down. And as you can see, under concrete pile, we have our own concrete pile. So I'm gonna change this to 600 and say edit type. And then I'm gonna say duplicate and then change this to 800 millimeter diameter pile and say okay. And then I'm gonna change the depth to 8,000 millimeters and then the diameter to 800 millimeters and say apply, okay, perfect. And now while it's still selected, I'm gonna copy it to the other grids. So I'm gonna say copy, and then from there I'm gonna copy 2,000 millimeters to the other grids like so. And then I'm gonna do the same thing this side. I'm gonna say copy from this grid to this grid, from that grid to that grid. Perfect. And now I'm gonna select my piles, and then from there I'm gonna copy them to the right and also to the left by 1000 millimeters. So it's 1000 millimeters this side, and then I'm gonna select them again and say copy, and then I'm going to copy them 1000 millimeters to the left. Perfect. If I go to the south elevation, so this is what we have. It still doesn't look right. So what I'm going to do is I'm going to select them all like this and then deselect this grid, and then I'm going to say move, and then from the top of your piles I'm going to move them down under our bases, but I want my pulse to be embedded into our bases at 150 millimeters. So while it's still selected, I'm going to say move again and then select it from the top, and then I'm going to embed them into my bases with 150 millimeter offset. Perfect. While they're still selected, I'm going to copy them to the other grids. So I'm going to say copy and then copy them from this grid to this grid, from this grid to this grid, and so on. Perfect. When I go back to my basis, my base floor plan, so when I open up my 3D view, this is what we have so far. So I'm gonna go back to my base level, and the next thing is we're gonna generate foundation, the base for our abutments. Now, for our abutments, obviously, when I go to the south elevation, they're going to be offset because the abutments have to be aligned with the concrete deck or the girder. So they're going to be, obviously, they're going to be offset above their bases. So let's just generate the geometry and we'll adjust the offsets on all those parameters afterwards. So we're going to go back to the structure, and under foundation we're gonna go with the isolated, and then drop down we're gonna go with the footing rectangular, and then we're gonna place it where the center line and the abutment grids are intersecting. So I'm gonna select my base. I'm gonna say edit type, duplicate, and then rename this one 18,000 millimeters by 6,000 by 2000 millimeters, and say okay. I'm gonna change the length to 18,000 millimeters, and then the width to 6,000 millimeters, and then the thickness is all right at 2000. I'm gonna say apply and then okay. And now while it's still selected, I'm gonna as you can see, we have pier 3 as our center vertical grid. So I'm gonna use it as my reference if I want to copy things to the other side. So it's sort of like a symmetrical bridge. So this grid is gonna make it easier for me to copy things to the other side. So while the base of my abutment this side is still selected, I'm gonna go to mirror pick axis and then pick this middle grid, and now it's copied to the other side. If I go to the 3D view, so this is what we have. And now I'm gonna go back to my bases again, and then I'm gonna apply my pulse on my abutment bases. So under foundation, I'm gonna go to isolated again. I'm gonna drop down, and then remember under concrete piles, I'm going to select my 800 millimeter diameter pile, and then I'm going to place it right in the middle like this. And now I'm going to select it, and then I'm going to copy them. So I'm going to copy the four of them I'm going to copy four of them this side and also this side, and then I'm going to copy one this side and also this. So I'm gonna select it and then say copy, and then I'm gonna copy them by 1500 millimeters. So it's gonna be four of them. So it's gonna be 4. Actually, let's go with 2000. Let's try and see what happens with 2000. So I'm gonna copy them by 2000, 1, 2, 3, and then 4. Perfect. And now I'm gonna select the four of these and then say mirror pick axis and then pick the center line grid, and then everything is copied to the other side. And then I'm gonna say control select these, and then I'm gonna copy them to the right and also to the left by 1500 millimeters. So I'm gonna offset them by 1500, and then while it's still selected, I'm gonna go to mirror pick axis and then pick this grid, and then it's copied to the other side. When I go to the south elevation, I have to adjust the offset. So I'm gonna select them, go to filter, and then uncheck the grids and say apply. Okay, now only my piles are selected, and then go to move, and then from the top I'm going to move it under the base, and then I'm going to embed them, say move again, and then from this point I'm going to move them. I'm going to embed them into my base at the offset of 150 millimeters and press enter. While it's still selected, I'm gonna go with mirror pick axis and then pick this middle grid, and then everything is copied to the other side. Go to the 3D view. This is what we have so far. Perfect. And now we are done with our bases, we are done with our piles, and what we can do is before we move further, let's just generate our schedule. It will obviously update along when we add more geometry to our 3D space. So I'm gonna go right click on our schedule and say new material takeoff, and then I'm gonna say multi-category material takeoff. Okay, and then I'm gonna type in on parameter name search, I'm gonna type in category first. I always start with it and then load it in. And then the second one is type, and then the third one is gonna be family, and then the fourth one is gonna be levels. Then load it in, and then we're gonna go with area, material area, and then we're gonna go with material volume, and then we're gonna go with count. And I think that is it. Actually, for the piles, we're gonna go with depth. Um, I have to know the depth of the piles and obviously the diameter of the piles. And then we're gonna say okay. Now we have opened our schedule. So the next thing is I'm gonna go to sorting and grouping edit, and then I'm gonna say sort by category, then by type, then by family. And then I'm going to add blank lines, and then I'm going to add my footings, and then I'm going to add my grand totals. And then I'm going to go to formatting and then select area and say drop down, calculate totals, and then material volume, I'm going to say calculate totals. And then I'm going to say okay, perfect. So this is what we have. Now you can close down your schedule, and then you can save your project as you go along. So I'm just gonna name it um, Better Bridge and say save. And now the next thing is we're gonna generate our pier shafts and our pier head. Now, for our pier shafts and our pier head, obviously they're gonna be placed on top of our bases. So before we generate families for that, just go to reference plane, and then for your reference plane, you're gonna say pick lines, and then you're gonna offset it from these outer grids by 1400 millimeters. So you're gonna say offset of 1400 millimeters, and then offset it from there. And then you're gonna do the same thing this side. Perfect. So this intersection is where you're gonna place your pier heads. Now for your pier heads, we're gonna use the column family template in order to generate it. So we're gonna go to file, new, and then family, and then drop down, and then you're gonna go with metric structural column and say open. And now our pier heads are going to be circle. So you're going to set your width to 2000 millimeters, and then also set your depth to 2000 millimeters. And then you can just extend your annotations just to see things more clearly. Extend it beyond your reference planes. And then when you go to the front elevation, so this is what you have. So it doesn't matter what height you set your upper reference level to, as long as you lock your geometry towards this reference level, you can control its height when you load it into your project. Because after all, no matter what geometry you generate, it will always behave like a column. So when you go back to the lower reference level, you can set up your geometry. So I'm going to go with create and then extrusion and say circle. And then from this insertion point, I'm going to draw my circle, which is going to be 2000 millimeters in diameter. And then before I'm going to say finish edit mode and then go to my front elevation. And then I'm going to drag my extrusion to the upper reference level and then lock it. And then press escape, and I'm gonna press AL on my keyboard for align, and then press the lower reference level and then my geometry and then lock it. And now I'm gonna open up a 3D view, select my pier shaft, and then apply material to this. So I'm gonna name it concrete. And then I'm just gonna make it the precast concrete, load it in, apply, and then okay. And then I'm gonna say load into project and close. I'm gonna save it as my pier shaft and say save. And then I'm gonna go to my basis level. And then on my basis level, I'm gonna go to under structure, I'm gonna go to column and then set it to vertical column, and then set my constraints to height, and then my upper level to PS. And then I'm gonna place my pier shaft where this reference plane and this vertical grid are intersecting. So I'm gonna place it like this. So perfect. And now when I go to the south elevation, and this is what we have. And now I'm gonna go back to my basis, and then I'm gonna place all my pier shafts. So while it's still selected, I'm gonna go to mirror pickaxes and then pick my center line grid, and then it's copied to the other side. I'm gonna say control select, and then I'm gonna copy them to the other grids. So I'm gonna say copy, and then from this point, I'm gonna say copy, 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 and then copy. And up the 3D view, our bridge is taking shape. So go back to the basis floor plan, structural floor plan, and then what you just go back to the 3D view and then select one pier shaft, and then right click and then select all instances visible in view, and then on your top offset you're gonna set it to minus 1800 millimeters. Perfect. Because when you go to the south elevation, your pier head is going to be 1800 millimeters in height. So I had to offset it by minus our pier shaft by minus 1500. So speaking of our pier head, we're going to generate our pier head using the column family template also. So you're going to go to file, new, and then family, and then you're going to drop down and say metric structural column, open. And now you're going to set your width to 11,200 millimeters, and then your depth you're going to set it to 1000. Actually you're going to set it to 2000, sorry, you're going to set it to 2000, and then just extend your annotations beyond your reference planes just so you can see everything more clearly. And then you're going to go to the front elevation, and then you can just extend your reference plans, and then you're gonna go to create and then a reference plane, and then you're gonna randomly place a horizontal reference plane like this, and then you're gonna offset it from the lower reference plane by 1200, and then set your upper reference level to 1800. So it's going to be 600. Perfect. And now what you can do is you're going to go to create, and then you're going to create your extrusion. So you're going to say extrusion, and then from this point you're going to take it down by you're going to take it down by actually go just press escape, and then for your left reference plane, you can offset it by, actually it's fine. So you're gonna say create and say reference plane again, and then randomly place two reference planes on on each side. Select one, and then you're gonna offset it from the middle reference plane by, so you're gonna say equals to 15,800 millimeters divided by 2, which is 7.9. You're gonna select this one also, and then you're gonna make it 7.9. And now you can create a geometry. So you're going to say extrusion, and then from this point you're going to take it to the left by 5006, and then you're going to take it diagonally to this insertion point, and then upwards by 600, and then to this point. And now you can select all your lines, go to mirror pick axis, and then pick your middle reference plane, and then it's copied to the other side. Select one line, remove it, and then make this a single line. Do the same thing on the bottom, and then select this one and then drag it to the left to make it a single line. Perfect. And now say finish edit mode, and then while your geometry is still selected, you can apply material to this. So you're going to say concrete, and then you're going to drop down. So I'm going to make everything precast. So I'm going to say apply, okay, go back to the lower reference level, and then I'm going to drag it to this reference plane and then lock it, and then drag this side to this reference plane and then lock it. Open up the 3D view, and this is what we have. Now I'm going to say load into project and close. I'm going to save this, and then I'm going to name this pier head and say save. And now I'm gonna open up the pier floor plan, structural floor plan, and as you can see we cannot see anything, so I'm gonna press VR for view range, and then I'm gonna set the top offset to 1000 millimeters, and then the cut plane to 1000 millimeters, and say plus apply, and then the bottom I'm gonna set it to minus 12,000, and then the view depth minus 18,000. Apply, okay. So now we can see everything. And now I'm going to select under structure, I'm going to select my column, set it to vertical, and then change my orientation by pressing the space bar. And then I'm going to set my height to pier. Okay, it doesn't work, so I'm going to change my orientation, and then place it like this, place my pier, go to the 3D view, and as you can see our geometry is very distorted. And now in order for us to remedy that, what I'm gonna do is I'm gonna set my base offset to minus 1800, and then the base level to pier, and then set the top level to piers. So it still doesn't work. So what I can do is I'm gonna set this to 0, and then the top, I'm gonna set the top offset to 1800, and then set the base offset to 0. So it still doesn't work. So I'm gonna go to edit family again, and then go to the front elevation, and let's see if everything is locked. So I'm gonna press my reference level, press my geometry, lock it, and the upper one, lock it, load it into project and close, save, replace it, override the existing version, and let's see what happens. So I'm gonna set this to minus 1000, and then set this to 0. So when I go to the south elevation, so this is my pier, this is my pier level. So if I select this and then set it to 1800, let's see what happens. So it still doesn't want to change. And then if I set this to 0, still doesn't want to change. So I'm gonna go to edit family again, and let's see if there's something am I missing. So the front elevation, I'm just gonna remove this reference level. Then just lock everything. Go into project, yes. Override the existing version. Perfect. Now it works. I had to lock the reference planes onto the geometry in order for us to control the height. So make sure the base of, let's just go back to edit family. Make sure, and then the front elevation, make sure you press AL for alignment on your keyboard, and then press your reference level, and then press the bottom of your geometry. You will see that the sign of a log will show up, and then you must log it, and then do the same thing on top, and then you can load it into your project. And then after that, you can select your peer head, make sure the base level is set to PS, and then the base offset is 0. The top level is also set to PS, and then the top offset is 1800. So I'm going to go to the south elevation, and then I'm just going to press move and then move it downwards. So I'm going to say unconstrained. So as you can see, it's on top, which it doesn't make sense. So I'm going to set it to, let's set it to 1000 minus 1800, and then the top offset to 0. So yeah, this is what I want. So this is how it's supposed to look. I'm gonna go to the south elevation, select my peer head, and then I'm gonna copy it from grid to grid. So I'm gonna copy it from this grid to this grid, from this grid to this grid, and then so on. Open up the 3D view again, and this is what we have. And now I'm gonna go back to the south elevation, and let's see what we have so far. So the next thing is, let's generate our apartments. So I'm gonna go to let's close down the base floor plan, and then we are in the PS structural floor plan. Now for the apartment, we're gonna use a generic model template. So we're gonna go with file, new, and then family, and then we're gonna drop down, and then we're gonna say metric generic model. So open. And now, as you can see, this is what we have. So we're gonna set up our uh, dimensions and parameters, and then we're gonna generate our geometry. So I'm gonna go with a reference plane, place 2 vertical reference planes on each side, and then from this side I'm gonna offset it by, so it's gonna be cos to 17,000 millimeters divided by 2, so it's going to be 8.5. And then this side also I'm going to make it 8.5. Perfect. And then I'm just going to unlock this and extend it just to show that it's the middle reference plane, and then lock it again. And then this one also I'm just going to extend it beyond and then lock it again. Perfect. And now the next thing is we can model our geometry, and then we can add parameters to that. So I'm gonna start with my bottom base. So my bottom base is we're gonna go with create and then extrusion, and then I'm gonna place a rectangle like this. Go with a rectangle, and then rectangle within the bounds of my reference planes. Then from this side I'm gonna offset it by 2000 200 millimeters, and then from this side I'm gonna offset it by 3000 millimeters. So the overall is gonna be 5200. And then I'm going to say finish edit mode, go to the left elevation, and this is what we have. So I'm going to hover over the top, press tab on my keyboard until the top line is selected, and then adjust the thickness. So the thickness, I'm going to make it 1000 millimeters. We're going to apply the material once we are done with everything. So I'm going to select this reference level, just extend it beyond like this, and this is what we have. And now the next thing is I'm gonna place my my top base where our bridge bearings are gonna be based. So what I'm gonna do is I'm gonna select this extrusion and say copy, and then I'm gonna say copy and then unconstrain, and then I'm gonna copy it on top, and then I'm gonna adjust the offset. So I'm gonna drag this one to the right until it meets this reference plane. So I'm gonna make it 2200 millimeters uh, in length. So I'm gonna open up the 3D view, and this is what we have so far. The next thing is I'm gonna construct my divider wall, and then I'm gonna go back to my left elevation. So my divider wall, I'm gonna go with create again and say extrusion, and then from this point I'm gonna take it upwards by 2222, and then I'm going to take it to the left by 400 millimeter thickness, and then take it down by 222 again, and then I'm going to make it 400. So I'm going to say finish edit mode and say go to the and then go to the reference level. As you can see, we cannot see everything, so press VR for view range, and then you can set your top range to 10,000, the cut plane to 10,000, apply. Okay, now you can see everything. Select your divider wall, drag it to the other side, and then drag it also to the other side. Perfect. Now open up the 3D view. This is what we have so far. The next thing is you're gonna apply your wing walls, and now that's like the last step of our geometry for our bridge abutment. So just go back to the left elevation, and then say create, and then go to reference plane, and then from this point draw a vertical reference plane like this, and then from this point also draw a horizontal reference plane like this, and then you're gonna set the offset to 1741, and then you're gonna draw a horizontal line like this, and then you're gonna say another offset of 794, and then you're gonna say pick lines, and then you're gonna pick this reference plane, and then you're gonna copy it like this, and then you're gonna set another offset of 700, and then you're gonna set it like this. So I think it's fine right there. And so another thing is you can go to create again reference plane, and then from this point you can say pick lines and then set the offset to 1500 millimeters, and then you can pick this reference plane, and then it's gonna copy it 1500 millimeters to the so to this side. So you're gonna now we can construct our wing wall. So we're gonna go to create extrusion, and then from this point we're gonna take it downwards by 3222, and then to the right by 3000, and then upwards by 1741, and then we're gonna take it diagonally to this insertion point, and then you're gonna take it 500 upwards, and then diagonally to this insertion point. Perfect. And now we're gonna say finish edit mode. Now you can just remove these temporary reference planes, and then go to the reference level, and then you're gonna drag your wing wall to the ends, and then you're gonna drag it this side. So you're gonna hover over here, press tab on your keyboard, and then you're gonna adjust the thickness of your wing wall so you can make it 300 millimeters. Select your wing wall, go to mirror pick axis, and then pick this middle reference plane, and then open up your 3D view, and this is what you have. Now the next thing is, obviously we have to apply parameters to that, but before I do that, I just want to log everything so that when I control one when I control one aspect of this bridge abutment, everything else moves with it. So, for instance, if I want to control the length of this bottom base, I also want this base to also increase in length or increase in width along with the bottom base, if that makes sense. So, in order for you to do that, you're gonna have to log every block or every geometry against each other. So I'm gonna type in AL for alignment and then press this side of my base and then press this base and then lock it. Do the same thing with the wing walls. So I'm gonna select this side of my base, select my wing wall, lock it. And then select this side of the base again, select my divider wall, lock it. And then I'm gonna do the same thing for this side. So I'm gonna select the side and then this wing wall, lock it, select the side of my base, this base, lock it, this side of my base, this side of my divider wall, and then lock it. And then this side also, lock it, and then this side also, lock it, and then lock it. Perfect. Now we can apply. I actually don't want to apply parameters. I just want to keep. I don't want to make this tutorial long. So I think I will try to keep it as static as I can. So I'm just gonna say load into project and say save this. So I'm gonna save this as an abutment and say save. And now I'm gonna go to my PS structural floor plan, and then I'm just gonna change my orientation by pressing tab, and then I'm just gonna place it right in the middle, like so. I'm just gonna place it like this, go to the south elevation. Then on my south elevation, this is what we have. I'm gonna select it, press tab just to change its orientation. And then as you can see, this is my breach abutment. Yes, so yeah, this is what we have. So I'm just gonna let me just check this side so I can see the levels. So my bridge girders are gonna be there. So I'm gonna select my bridge abutment and then move it and then drag it downwards until it's placed right there. Actually, I'm gonna place it right there. Yeah, perfect. So our bearings are gonna be based there, and then our girders are gonna be based there. So yeah, I think it's perfect, at least in my opinion. So what I'm gonna do now is I'm gonna say architecture and say reference plane, and then pick the middle of this, the side of my bridge abutment, and then draw my reference plane just to use it as a reference. And now I'm gonna drag my bases and my pulse for my abutments towards this level, towards this point. So I'm gonna select all of them like this and say filter, and then I'm gonna uncheck the grids and levels, apply, okay, and then I'm gonna say move, and then from this, the middle of my base, I'm gonna drag it upwards to this point. Perfect. And now while they're still selected, I'm gonna say control select my abutment, and then I'm gonna say mirror pickaxes, and then pick this grid, and then everything is copied to the other side. So now I'm gonna say select all of these, filter, and then uncheck the grids and levels, say okay, and then I'm just gonna remove this. Go to my 3D view, and then we are almost there. So I think when let me just select my abutment again. We didn't apply material, so I'm gonna select everything. Go to material, and then type in concrete, and then I'm gonna drop down. I'm gonna say precast concrete, apply, okay. Load into project, save, replace, override existing version and its parameters. Yeah, so this is what we have. And now the next step is we're gonna generate our bearings. But before that, let's just check our quantities for our concrete so far. So it's increasing. So this is valuable information. You can take this to the foremans on site. You can take it to the site agent, and they will check if there are any discrepancies between what you have on your 3D model and what the consultants gave them in terms of the 2Ds. So it's very much valuable. So yeah, anyway, let's go back to our model. We're gonna generate our bearings. So this is one of my favorite aspects of a bridge, which are the bearings. So for our bearings, we can let's just go back to the PS floor plan. Let me just see. Yeah, let's just go to the PS structural plan. For our bearings, we're gonna go to new family, and then we're gonna use we can use metric generic model, just like the abutments. I think it's fine. The first thing is we're gonna go to the front elevation, and then we're gonna set up our levels using the reference planes. So you can randomly place your reference level. So you can select it and then offset it by 40 millimeters from this lower reference level, and then you're gonna say copy, and then you're gonna copy it upwards by 60 millimeters, and then further 422 millimeters, and then another 60 millimeters, and then another 40 millimeters. So this part, the objects I'm gonna place there are gonna be the same thing I placed here. The only thing is gonna be different is what I place in the middle. So let's start with our first layer. So we're gonna go to create and say swept blend. Go to sketch path, and then we're gonna place it right in the middle, and then like this. So it's gonna be 40 millimeter in thickness. So it has two profiles. The first one, which is here, the second one it's here. So we're gonna say finish edit mode, select profile one, edit profile, and then it's going to take you to the floor plan reference level open view. And now you're going to randomly place a rectangle like this, and then adjust the offsets. Select the side, and then from the middle reference plane, you're going to offset it from the right by, so it's going to be 450 millimeters, and then the overall depth, the overall width is going to be 900. So it's going to be the same case this side. So you're going to make it 400, and then the overall is going to be 900. What am I doing now? So the overall is going to be 900. Perfect. So you're going to say finish and say select profile 2, edit profile, and then select your rectangle, randomly place it like this, and then select one side, and then you're going to adjust this side by equals 2, so it's gonna be 825 divided by 2, which is 412.5, and then you're gonna select the side and make it in 825, and then you're gonna do the same thing this side. So it's gonna be equals 825 divided by 2, 412.5, select the side and then make it 825. Perfect. And say finish edit mode, open up the 3D view, and this is what you have. Now let's just change this to realistic, apply the material to this. So you're gonna name this one concrete. So it's basically your epoxy, so you're gonna make it concrete. So it's usually cast in place, so we can just select this one, concrete cast in place, gray, load it in, apply, okay. And now go back to the left elevation. So yeah, we open up the left elevation, and then the next thing is we're gonna place our steel plates, so which is on top of our epoxy. So for that, you're gonna go to create again, extrusion, and then you're gonna place a rectangle from this point, which is the same in width with the top of your epoxy. So you're going to place it like this and say finish edit mode, go back to the reference level, and then you're going to drag it to the other side. So when you go to the 3D view, this is what you have. Now you can select your extrusion, and then change its material. So you're gonna make this steel, so it's a steel plate. So we're just gonna use steel S355, load it in, apply, and then okay. And now go back to the left elevation. So everything from the top is the same, everything from the bottom is the same with the top. So I'm gonna select my two extrusions and then say mirror draw axis, and then I'm gonna randomly place my axis like this horizontally, and then it's gonna be copied to the top, and in reverse it's gonna be mirrored. And then I'm gonna say move, select this point, and then adjust it like this. Go to the 3D view. So this is what we have. So the last part of our bearing is the elastomer, which is basically made of sort of like a rubber material, but it's very strong and it's used for seismic testing. So yeah, it makes the bridge much more durable and easier to bear movement such as earthquakes and all that. So yeah, let's just go back to the left elevation. So you're gonna say create extrusion, and then you're gonna uh, draw a random rectangle like this using these points as a reference. But you're gonna adjust it. You're gonna make it. You're gonna make it 700 and you're gonna make it 770 millimeters in width and also in length. So I'm gonna adjust it from this point. I'm gonna say equals to 770 divided by 2, so it's gonna be 385. And then this side I'm gonna select it and make it 770. Say finish. Go to the reference level, and then I'm gonna hover over here, press tab, and then this side I'm gonna make it equals to 770 divided by 2. And then I'm gonna hover over here, press tab, and then select this. Actually, I'm gonna apply the dimension for this extrusion, and then hover over here, press this line, and then I'm gonna make it 770 this side, so it's gonna be like that. Yeah, go to my 3D view. So this is what we have. I'm gonna select my extrusion, and then I'm gonna type in rubber, and then I'm gonna say load in rubber natural and say apply. Okay, I'm just gonna keep it as simple as I can. Now I'm gonna say load into project, save. So I'm gonna name this elastometric, elastometric, elastome, yeah, elastometric bearing, and say save. Now it's loaded into our project. I'm gonna go to peer, and then I'm gonna place it where the grids of my girders are gonna be placed. So it makes it easier that way. So I'm gonna start with my peers. I'm gonna place it like that. And then I'm gonna select one, right click, select all instances visible in view, and then I'm gonna copy them to the other peer heads. I'm gonna open up the 3D view. So this is what we have. So it's really taking shape. So I'm gonna say control, select these, go to the south elevation, and then I'm gonna say copy, and then from this point I'm gonna copy them to our bridge abutments. So I'm gonna actually copy them towards the grids of our bridge abutments, but obviously I'm gonna say escape and then set this to wireframe. Obviously they are clashing with my divider wall, so while they're still selected I'm gonna say move, and then from this point I'm gonna drag them. I'm gonna move them with an offset of 800 millimeter from this grid for my apartment. So while it's still selected, I'm gonna say mirror pick axis, and then pick this middle Great, and now everything is copied to the other side. Open up my 3D view. So this is what we have. Now the most interesting part is our type V girder, which is in accordance with the American Association of State Highways and Transportation officials. So ASHTO. So we're gonna create it using a beam family template. But before that, let's just, before I forget, which is a very tiny detail, I'm gonna add a cobble for our abutments, and also the approach slab. So for our cobble, we're still gonna use a beam family template. So I'm gonna go. Let's just go back to my peer structural floor plan. Open up, go to file and say new family, and then you're gonna drop down and say metric structural framing beams and braces. Open. And now you're gonna delete this extrusion, remove this reference plane, and then remove these extra reference planes. And now you're gonna say left elevation, and then for your cobble you're gonna say create and say extrusion, and then set your reference to reference plane left and say OK. And now from this insertion point, you're gonna take it down by 500 millimeters and then press escape. And then from this insertion point, you're gonna take it to the right by 300 millimeters. Perfect. And then you're gonna take it down by 300 millimeters, and then you're gonna take it diagonal until this insertion point. And then you're gonna set your material and then just make it a precast concrete and say OK, and then finish edit mode. Go to the reference level, drag it towards this reference plane, and then lock it, and then drag it towards this reference plane, and then lock it, and then load into project and close. I'm gonna save this and then name it Cobel, and then save. And now I'm gonna go back to my peer structural floor plan and then go to structure. Under structure, I'm gonna go with beam, and then I'm gonna place my Cobel. So obviously my cobble is going to be set from within the bounds of my wing walls. And then what I'm going to do is I'm going to go to section and then cut a section using the center line as my reference. And then I'm going to double click here and then reduce, set this to fine. And then as you can see, this is my cobble. So it's orientated the wrong way, so I'm just gonna change it. Let me make it. So I'm just gonna remove this. Go back to your peer floor plan, go to beam, and then place it from this point to this point, and let's see what happens. Go to section 1. So go to beam again, and then place it from this point to this point. Let's see what happens. So I don't know why the orientation is not working. Let's see. Let's just place it from this point to this point. It's looking like that. Okay, I want this side to face this side. So actually, no. Actually, it's fine. I don't know what I was thinking. Okay, we're gonna manually adjust this. So in order for us to adjust this manually, you're gonna have to punch in any number on your start level offset and end level offset. That way you can move it more freely. So I'm gonna change this to 100, and then I'm gonna say move, and then from this insertion point I'm gonna move it towards this point. This is the deck level, and then the top of your divider wall for your abutment. But I'm not gonna stop there. I'm gonna say move again, and then from this point I'm gonna take it down by 300 millimeters. So our approach slab is gonna be based on top of this cobble. This cobble is gonna be supporting our approach slab. So I'm gonna go back to the peer floor plan. I'm gonna type in VR and then set top offset to 15,000 millimeters, and then the cut plane to 15,000 millimeters. Apply. Okay, perfect. Now we can see our cobalt. So now this is a great reference in order for us to place our approach slab. So for our approach slab, under structure, we're gonna go to floor, edit type, and then duplicate, and then you're gonna name this 300 millimeter approach slab, and then you're gonna say okay, and then under structure edit, you're gonna remove all these layers. Just remove all the layers, so you're gonna be left with one. So it's gonna be concrete precast, so it's fine. Then you're gonna make the thickness 300 millimeters and say apply. Okay, and then the first one, you're gonna place it like this on top of your cobalt, which is going to be 300 millimeter in length and 300 millimeter in thickness, and say finish edit mode. Open up your section 1, and then you're going to say move, and then you're going to move it on top of your cobalt, and then you're going to place another approach slab which is running at an angle. So go back to your PS structural floor plan and say floor again, and then your approach slab is still selected, and then select your rectangle option, and then from this point you're gonna place your approach slab until this point, and then you can select this line and then adjust the length of your approach slab, so you can set it to 5,000 millimeters, and then you're gonna say slope arrow. From the middle, you're gonna place your arrow towards this way. Set the height of set the tail to 0. Set the specification from height to tail to slope, and then set the slope to -5 degrees. And say finish edit mode. You go to your section, select move, and then from this insertion point, you can manual place it like this. Perfect. Now go to your 3D view. This is what we have. And now you can say control select your approach slab along with your cobalt, and then you can go to the south elevation, and then you can say mirror pickaxes, and then pick this middle grid, and then everything is copied to the other side. Open up the 3D view, and this is what we have. Before we can go to our concrete girders. Before that, let's just go back to our material takeoff and see the quantities. So definitely it is growing. So yeah, very much valuable information. So you can just close this. For our girders, we're gonna design them in accordance with ASHTO. So we're gonna go to File, New, and then Family, and then you're gonna drop down and then go to metric structure of framing beams and braces. Open, and then you're gonna remove this extrusion that comes with the template, and then this reference line, and then these extra reference planes. And now you can just extend this annotations beyond, and then set the level from 3000 and then set it to 30,000 millimeters. So what you can do is you're gonna say just increase the scale to 1:100. Yeah, just make it 1:100. Uh, Unlock this reference plane and then extend it beyond like this, and then lock it again. So go to create reference plane, and then add two extra reference planes on each side. So you're gonna adjust this one. From this point, you're gonna make it 2000 millimeters. Just remove this annotation. This side also, you're gonna make it 2000 millimeters. So your bridge girder is gonna consist of actually three parts. So the middle part is gonna be the girder web. This part is gonna be the end block. Also, this part is gonna be the end block. So it's three parts. So your girder web is gonna be 26,000 millimeters in length, and your end blocks are gonna be 2,000 millimeters each. So overall, it's gonna be 30,000 millimeters. So we're gonna go to the left elevation in order for us to generate our profile, and this is gonna be like it's gonna be much more complicated in terms of how we set up our references to set up our geometry. So yeah, let's go in. uh I'm gonna say extrusion, and then set the reference plane to reference plane left, and then from this insertion point I'm gonna take it to the left by, so it's gonna be equals to 1067 divided by 2. So it's gonna be 533.5. I'm gonna take it down by 127. Press enter. From this point, I'm gonna say create and say reference plane, and then I'm gonna set my offset to 76 millimeters, and then from this point, I'm gonna draw my reference plane, and then I'm gonna select my reference plane and say copy, and then I'm gonna take it further down by 102 millimeters. Perfect. And now I'm gonna say create again, reference plane, and say I'm gonna select my line, set the offset to, so it's gonna be close to 203 divide by 2, and then I'm gonna place it like this. And then I'm gonna select this reference plane and say copy, and then from this point I'm gonna copy it by 102, and then I'm gonna, so it's gonna be copied further by 100 and 330. So yeah, that's perfect. And now the next thing is I'm gonna select my line, and then from this insertion point I'm gonna take it diagonal to this point, and then this point, and then I'm gonna take it down by 838. So I'm gonna select my line again, take it down by 838, enter. Perfect. And now I'm gonna go to create and say reference plane again, and then I'm gonna set I'm just gonna draw a reference horizontal reference plane like this, select it and say copy, and then from this point I'm gonna take it down by 254, and then I'm gonna take it down further by 203, and then I'm gonna select my reference plane again and set my offset to, so I'm gonna say equals to 711 divided by 2, so it's going to be 355.5. So I'm going to select this line and then set it like this. So yeah, that's perfect. And then actually let me check, let me just confirm. Oh yeah, that's perfect. And then I'm going to select my line, and then from this point I'm going to take it diagonally to this point, and then I'm going to take it down like this, and then like this. And now I can just say select everything, filter, check none, reference planes, apply, okay, and then I'm gonna delete my reference planes. Select my lines, go to mirror pick axis, pick this middle reference plane, and then everything is copied to the other side. Now I'm gonna remove this line and then just join this to make this a single line. Do the same thing at the bottom. I'm gonna say make this a single line, and that's perfect. Apply the material to this. I'm gonna make the precast concrete, okay, and say finish edit mode. Go to my reference level and then drag my geometry towards this reference plane and then lock it, and then drag it towards this reference plane and then lock it. Open up my 3D view just to see my progress, and then just change the level of detail and see what we have. So yeah, this is what we have. And now for our end blocks, it's going to be much easier considering we have this geometry as our reference. So I'm going to go to the left elevation, and then I'm going to say before our elevation, go back to the reference level and then say create and then you're going to say swap blend for your two profiles and say sketch path, and then from this point you're going to sketch a path until this point, so it's going to be 2000 millimeters in length. Say finish, select profile 1, edit profile, set your reference to left elevation, open view, and then you're gonna select this profile as it is. So you're gonna say pick lines, press tab on your keyboard until you see these blue lines highlighting the entire geometry, and then make a single click so that everything can be selected. Perfect. Say finish, select profile 2, edit profile, and then for your second profile is going to be much different. So you're going to trace over the bottom as it is until this point, and then at the top also until this point, and then until you meet the middle of this diagonal, the midpoint of this diagonal line, you're going to take it downwards like this. Actually, from this point you can take it upwards until they meet like this, and then from this point until you meet the midpoint of the diagonal line at the bottom, you can take it upwards like this, and then you're going to trace over the top part like that. So this side is wrong, so you're gonna take it like this. Then you're gonna say finish and say finish edit mode, go to your 3D view and check what you have. So this is what you have. So you're gonna select your extrusion, apply the material, concrete precast, and say OK. Select your geometry, go to the reference level, and say mirror pick axis. Pick the middle reference, and then it's copied to the other side. And now remember that we are using a beam family template. When we generate our geometry, or when we place our bridge girder, I want this geometry to move along with the main geometry, which is the web. So in order for us to make it an intelligent family whereby the different geometries move together, we have to lock them against each other. So you're gonna press AL on your keyboard for alignment, and then first you're gonna press this reference level, and then your end block, and then lock it, and then your end block again, and then your girder web, and then lock them against each other. This reference plane, and then your end block, lock it. Also this side, the same logic. This reference plane and your end block, lock it. Your end block and your girder web, and then lock them against each other. This reference plane and the end block, lock it. And now everything is all set. You can say, sorry, you can say load into project and close, and then you're gonna say save, and say you're gonna name this Astro Type V Girder. Save, and now you're gonna go to Peer. Actually, you're gonna open up the Girder structural floor plan, and then set the type in VR, and then set the bottom offset to minus 12,000 and the view depth to minus 18,000. Apply just to see the grids, and say OK. And then you're gonna say under structure, you're gonna say beam, and then from this point you're gonna draw your girders. So you're gonna drag it until this part. So open up the 3D view, select your girder, and then remember I told you to control this manually because it behaves like a beam. You have to set up your start level offset manual and your end level offset. After that you can move them freely. So I'm gonna type in AL for alignment, and then select the top of my bearings, and then select the bottom of my girder, and now it's on top of my bearings. So I'm gonna select this. It seems like the material is not applied, so I'm gonna select all my geometry, Oh, so it's a precast. It's also a precast. So load into project and close, save. So yeah, it's also a precast. So it's perfect. I'm gonna select my girder again, go back to my girder structural floor plan, and then I'm gonna copy it to the other grids. So girder 2, girder 3, and then on my center line, girder 4, girder 5, girder 6. And now I'm gonna say right click, select all instances visible in view, and then I'm gonna say mirror pick axis and then pick this grid, and then also pick this grid so that I can copy everything, pick this grid, and then this grid, and also this grid. Go back to my 3D view, and this is what we have. Now, the last thing when it comes to girders we have to place is the deviator, which is sort of like when I go to the south elevation, which is sort of like a beam type of member which is placed right in the middle. So I'm going to say architecture, reference plane, and then find the midpoint of my girder and then place a reference plane like that. So for our deviate, we're going to use a precast beam. So we're going to load it in from Autodesk library. Just go back to the Gather floor plan and then go to Insert, Load Family, Metric Library, UK Contents, and say Structural Framing, and say Precast Concrete, and then use Precast Rectangular Beam, open. Go to Structure, go to Beam, and then as you can see, we have our precast beam, edit type, duplicate, and then you're going to name this 1200 millimeter by 8, 838 millimeter deep deviator. So you're gonna say okay, and then set the height to 838, and then the breadth to 1200. Apply, and then okay, and and then you're going to use this intersection point of the reference plane and the grid as an insertion point. You're going to adjust the level after until this point. So go to section, place a section right there, and then just extend it so you can see your deviator, and then open up your section. Select your beam and then adjust the offset. Type in 100 for your start and end level offset, and then you're gonna select your beam. Just set this to wireframe, select your beam, and then from the top you're gonna set it until this. Actually, what you can do is go to architecture reference plane, and then from this point draw a reference plane and say aligned, and then align to this reference plane. So this is what we have. As you can see, it clashes, so from this point you can adjust it to this point and then this point. Just extend your section, go to the floor plan again, and then okay, I think it's fine. Go back to section 2, select your deviator, and then actually close down your section, sorry, and you can say VR for your view plan. You can say VR and then set your top level to 1000 millimeters and then your cut plane to 1000 millimeters. Apply. Okay. Now you can see your deviator selected and say copy, and then you're gonna copy it between the other concrete girders like this. So this is what you have when you go to the 3D view. This is what it looks like. Perfect. Now you can say control, select your deviators. Or you can say right click and select all instances and then go back to your Geta floor plan. And then you're going to say mirror pick axis and then pick your grids, and then they will be copied to the other side. Open up the 3D view, and as you can see, this is the progress of your bridge. So remember to save it. And now the next thing is we have to generate our concrete. We have to generate our concrete slab, which is gonna be set on top of our concrete deck, which is gonna be set on top of our girders. So in order for us to do that, we're gonna have to use the beam family template again. So you're gonna go to new family, drop down, metric structural framing, beams and braces, and say open. You're gonna select your extrusion, remove it in the reference plane and these extra reference planes. And just extend your annotations. And now you can change the length to 30,000 millimeters. And then and just change the scale to 1:100. And now for your concrete deck, before we model our concrete deck, I just want us to load in our concrete girders in order for us to use them as a reference to model our profile for our concrete deck. So we're gonna go to insert, load family, and then we're gonna go to where you saved your families. Just go where you saved your families. So concrete girder model, and then Astro type V girder. I'm gonna say open, and then I'm gonna go to create component, and then I'm gonna place it right in the middle like this. Perfect. And then I'm gonna select it, and then remember our girders are 2000 millimeter offset, so there are two of them this side, so it's gonna be 2000, 2000, 2000. So it's three this side, three this side. So I'm going to select the three of these and say mirror draw axis. And then from this middle girder, I'm going to draw my axis, and then everything is copied to the other side. Perfect. Now I can go to the left elevation and then draw the profile of my concrete girder. So I'm gonna go with create extrusion and say set the reference plane to left and say okay. Now from this point, I'm going to draw a horizontal line until this point, and then I'm going to take it down like this. And also this side, I'm going to take it down like this. I'm going to say pick lines, set the offset to 250 millimeters, and then I'm going to pick this entire line. And then I'm going to make this line 15,800 millimeters. So it's going to extend on both sides. And then this side, I'm going to take it down by this side. I'm going to take it diagonally at so I'm going to take this down until this reference point and then diagonally to this point. So this side also, I'm going to take it down to this reference point and then diagonally to this point. Perfect. And then I'm going to apply the material to this precast concrete. Okay. And then I'm going to say finish edit mode, reference level, and then I'm going to select my geometry, drag it to the other reference plane, and then lock it, and then drag it to this reference plane, and then lock it in order for me to control its length on my project. I'm going to open up the 3D view, so this is what it's going to look like. So select your girders, and then remove them. And then you're going to say load into project, save. So you're going to save this as a concrete deck and say save. Sorry about that. And say I'm gonna open up the deck view, structural plan, sorry, and then I'm just gonna close these down. So I'm gonna go to structure. Under structure, we're gonna go with beam, and then from this point I'm gonna draw my deck until this appear. And then I'm gonna go to 3D view. Then on my 3D view, remember it acts as a beam, so I'm going to set the start level offset to 1000 along with the end level offset to 1000. And as you can see, this is what we have. So I'm gonna go back to my deck view, select my section, set my section on this point, and then I'm just gonna reduce the extent, open up this section, select my concrete deck, and then move it down until it's on top of my girders. So this is how it looks like. So if I just move my section to this point, and then just to show you how it looks like, and then drag this down, drag my grids upwards, set the scale to 1:50. This is how everything looks like. So this looks like a construction model of a bridge, very much valuable. So I can just, anyway, I'll close this down, select your concrete deck, and then say mirror pick axis, and then pick your grid, and then it's gonna be copied to the other side. Do the same thing until everything is in place. Perfect. Open up the 3D view. So this is what you have. So you're gonna save this, and now before we place our asphalt material, we're gonna have to place our concrete, our parapets. So for our parapets, you're gonna use the beam family template again. So go back to the deck floor plan, and then you're gonna say file, new, family, and then you're gonna scroll down, matrix structural framing, beams and braces. Remove that extrusion reference plan, your references. Then you're gonna set the length to 3750 millimeters, and then you're gonna go to the left elevation. You're gonna say create extrusion, and say set the reference to reference plane left, and then you're gonna say from this point you're gonna take it to the right by 285 millimeters and press escape. And then from this point you're gonna take it down by 400 millimeters, and then to the right by 200, and then you're gonna take it upwards by 1000 millimeters, and then you're gonna take it to the left by 300 millimeters. Perfect. So you're gonna, from this point you're gonna take it upwards by 120 millimeters, and then from this point you're gonna take it diagonally at an angle of 75 millimeters, along with actually you're gonna take, you can take it down by 200 millimeters at 80 degrees, 80 degrees, and then you're gonna select your start and radius arc from this point to this point, and then you're gonna place it like this. So it really doesn't work, so just remove this. Let's just work on this side first. So this side you're gonna say your line, and then set your your chamfer at 30 millimeters this side, and also this side 30 millimeters, and say trim and extend, trim and extend, trim and extend, trim and extend. And now you're gonna say your line again, and then you're gonna offset it by 200 millimeter from the top, and then you're gonna take it down by 45 degrees at 60 millimeter length, and then go down by 180, and then another 45 degrees at 60, and then press SL on your keyboard for slice, and then pick this point to slice your line, and then select this line and then remove it. Add your chamfer again at 30 millimeters, and then draw a diagonal line, go to trim and extend, trim and extend. Now from this point I'm just going to extend it and make it to 200 millimeters, and then from this point I'm gonna draw a vertical line by 200 millimeters and draw another diagonal line until this point, And then I'm gonna draw a chamfer at 30 millimeters and then diagonal line, trim and extend again, trim and extend. And now I'm gonna add my fillet between these two. So I'm gonna select these two lines and then add a fillet of 225. I think it's fine. And then from this point, another fillet. This one I'm gonna make it 300 millimeter radius. So I think it's perfect. Or I can just reduce it and make it. Let's try 150. Yeah, I think 150 works. So this one I'll also reduce it and make it 150. And let's see how it works. I think it also works. So I think this part is it's a bit I have to extend. I want to extend this. So let me just extend this and make it 280, and then I'll draw my diagonal line and add my fillet. And this one I'm gonna make it 150, and then add my fillet here. This one also I'm gonna uh, make this 175. Yeah, so this one is fine at 150. So this one I'll adjust it and make it diagonal until this point, remove this chamfer, and then add my chamfer again. So I'm gonna add a vertical line like this, selected just to use it as a reference. And from this point, I'm gonna offset it by 30. And then I'm gonna draw diagonal line from this point to this point, remove this line, trim and extend, trim and extend. Perfect. Now I'm gonna add material to this precast concrete as always. Finish edit mode, go to reference level, drag it to the other side, lock it, drag it to this side, lock it. Open up the 3D view, set this to realistic, and this is what we have. And now I'm gonna say load into project. I'm gonna save this and name it parapet and say save. And now I'm gonna go to my deck structural floor plan, and then under structure I'm gonna go to beam, and then from this point I'm gonna draw it by and make it 3750 in length. And then I'm gonna draw a section just to see this parapet, how it interacts with my deck. Open up my section, reduce the scale, make it 1 is to 50, change this to fine, select it. As you remember, it behaves like a beam, so I'm gonna set my start level offset to 100 along with my end level offset to 100 just to manually control it. And then I'm gonna say move, and then from this insertion point I'm gonna place it like that. Go to my deck, and this is what we have. And now I'm gonna copy it from this point to this point. So I'm gonna copy multiple of them. Perfect. Now I'm gonna say right click, select all instances visible in view, and then I'm gonna say mirror pick axis, and then pick my center line, and then it's copied to the other side. And then right click again, select all instances visible in view, and then I'm gonna say pick mirror axis, mirror pick axis, pick this grids, and then it's gonna be copied to the other concrete decks. Open up the 3D view, and this is what we have so far. So if I open up, before we add our asphaltic material, if I open up my multi-category takeoff, as you can see, the quantities are increasing. So we have our parapets, and they generate about 102 cubics of concrete. So I'm gonna close this down. And now for my asphaltic material, it's gonna be easier. We're just gonna use a floor. Just go back to the deck structural floor plan. We're gonna go with under structure. We're gonna go with floor and say edit type, duplicate, and name this 100 and 150. millimeter asphalt. Say okay, edit, set the thickness to 150, set the material to asphalt, and then you're gonna choose this one, asphalt pavement, dark gray, load it in, apply, and then okay. Say okay, apply, okay. And then you're gonna select your rectangle, and then from this point, you're gonna place it until your grids. So you're gonna break it down into sections. So you're gonna say finish and say go to your 3D view and then set your offset to, so it's gonna be equals to 150 plus 250 for the deck. So it's gonna be set like that. Select your asphalt, go to your deck view, mirror pick axis, and then pick your grids so that it can be copied to the other sides. Go to your 3D view, and this is what we have. Perfect. And now the last thing we're gonna model is our concrete barriers for our roads. So in order for us to do that, the same logic as the parapets, we're gonna go to File, New, Family. You're gonna drop down Metric Structural Framing, Beams and Braces, Open, and then we're gonna remove your extrusion, your reference line, your extra reference planes, and then you're gonna set this to 3,750 millimeters, and then go to the left elevation and then generate your geometry. So you're going to say create extrusion, set your reference plane to reference plane left, and then from this point, you're going to say equals to 610 divided by 2, which is 305, and then you're going to take it upwards by 200. Actually, let's do this. So delete everything, go to create reference plan, and then from draw a horizontal reference plane, and then select it, set the offset to 922 millimeters, and then go to create again reference plan, and then you're gonna say uh, 152 equals to 152 divided by 2, and then you're gonna draw a vertical line and set it like this, and also set it also this side. And then from there, you're going to select your line and say copy, and then you're going to copy it further by 114 millimeters. Then you're going to do the same thing this side. And then from this point, you're going to say copy and then copy it upwards by 330 millimeters. So yeah, this is what you have. And now you're going to say you're going to create your lines now. So from this point, you're going to take it to the left by 76, and then diagonally to this point, and then you're going to do the same thing this side, diagonally to this point, and then at 45 degrees you're going to generate the length of 200 millimeters. Actually, you can make it 300 and then take it down by 117.5, and then to this point. Now, so you can select your lines and say mirror pick axis and pick this middle reference plane, and then everything is copied to the other side. So remove this line, make this a single line, apply the same logic at the top, make this a single line. Perfect. Now you can move your temporary reference planes. Then you can apply the material to this. So you're going to make this precast concrete okay and say finish edit mode. Reference level, and then you're gonna drag it to this reference plane, lock it, and then to this reference plane, and then lock it, and then open up the 3D view. So this is what you have. So you're gonna say load it new project, and say you're gonna save it yes, and then you're gonna name this barrier. Say save, and then you're gonna go to your deck level, and on your deck level, you're gonna say under structure, you're gonna say beam, and then from the middle you're gonna draw your barrier. So you're gonna make it 3750, and then you're gonna go to your 3D view, and then you're gonna have to find your deck. It's gonna be embedded, and then you can just set your start level offset to 1000, and also this one 1000, and then you can just press AL or align on your keyboard, and then press the top of your ashball and the bottom of your barrier, and then it's gonna be set like this. Go back to your deck level. You can't see anything. Press VR. Set the top level to 1500. The cut plane to 1500. Apply. OK. Now you can see your barriers. Select your barrier and then copy it along your spans. So you're going to select one barrier, right click, select all instances visible in view, go to mirror pick axis, and then pick your grids so that you can copy them faster to the other sides. Open up the 3D view, and there it is, folks. There it is. That is our concrete girder bridge. Level of detail 300 to 400. So yeah, I hope you guys enjoyed this tutorial. I actually did. This is one of the best I've ever done. I felt confident about this one. So here is our schedule. So if you want to push this schedule to Excel, you can just go to File and say Export, and then you're gonna drop down, and then under Reports you're gonna say Schedule, and then set it to CSV, and then you can save it, and then leave your settings like this and say OK, and now it's going to be exported to Excel. So thank you guys for watching. I hope you stuck through this tutorial. It was very long, I must admit, but I think it was very valuable. Oh, the one thing I almost forgot. Yeah, very tiny detail. It's our blindings. So go back to your bases, and then for your piers, you can just under foundation, you can go to slab and select your rectangle, and then just use your basis as your reference. Go to edit type, duplicate, and then name this 75 millimeter blinding layer, and say OK. Edit, set this to 75, and then select concrete cast in place. OK, OK, apply, and then OK. Finish edit mode. Go to the south elevation, and then as you can see, this is change this to fine. This is your blinding. As you cannot see it actually, it's actually on top of your base. So you're gonna say move, and then from the top of your blinding, you're gonna move it downwards until your base. While it's still selected, you're gonna say copy, and then copy it from grid to grid. And then you're gonna do the same thing for your just go to your PS. You're gonna do the same thing for your abutments. Just go to select one of your blindings, and then copy it towards the basis of your abutments, and then go to your base floor plan. Set this to wireframe. Just select your blinding again, go back to your PS floor plan, edit sketch, and then align, and then on you can align it according to the size of the abutment base. So you're gonna say finish edit mode. While it's still selected, you can say mirror pick axis and then pick this middle grid, and then it's gonna be copied to the other side. So when you go to a multi-category material, and then we're gonna drop down, let's check for our blinding layer. Let's check if it's generated. So that okay, where is our blinding? Where is our blinding? Oh, there it is. So there is our blinding. It consists of 31.95 cubes of concrete. So yeah. Now back to the 3D view. This is what we have, guys. I hope you guys have enjoyed this tutorial. I certainly did, and I will see you on the next tutorial. Please like, subscribe, and comment, and let's meet again. I'm still working on that Patreon whereby I do these types of projects, but I take it further when it comes to that. So yeah, I will fill you in when it comes to that. Yeah, so have a great day, have a great evening. I'll see you guys on the next tutorial. Peace.